Silicon is a metalloid. Its chemical symbol is Si. It is the 14th element in the periodic table. It belongs to the group 14, carbon family. Elements in the group 14 are called tetrals. The word silicon derived from the Latin word silex or silicis, meaning flint. Some chemists thought it was a metal and some thought it was a non-metal like carbon. It was discovered and isolated its amorphous form by Berzelius in 1823. Its crystalline form was isolated by de Ville in 1854. Mainly, silicon exists in two different forms: crystalline form with a beautiful metallic luster and amorphous form in dark gray color. Silicon is not a very chemically active element. It is not affected by air or water at room temperature. Like carbon, silicon combines with most elements only at elevated temperatures. Silica is the main and cheap source of silicon. In industries, they use charcoal to reduce silica at very high temperatures. Although it is the cheapest method, it doesn't suit for normal laboratories. In a laboratory setup, magnesium is often used to reduce silica. As I mentioned earlier, elemental silicon is unaffected by water at room temperature. Silicon is highly resistant to most acids, but it reacts vigorously with hot aqueous alkalis. Here it reacts energetically with hot sodium hydroxide solution to produce sodium silicate with the evolution of hydrogen. Like carbides, silicon combines with metals at high temperatures to produce corresponding metal silicides. Here silicon reacts with magnesium at elevated temperatures to produce magnesium silicide. Actually, this has to be done in a closed vessel in order to increase the yield of magnesium silicide. I just wanted to show you how they combine on strong heating in the presence of air. Since silicon is a metalloid, it exhibits properties of both metals and nonmetals. Like a metal, it combines with some nonmetals on heating. Here I'm igniting a mixture of silicon and sulfur with the help of magnesium ribbon. At elevated temperatures, silicon combines with sulfur to produce silicon disulfide.